Angles of elevation and depression. Objective. Students will use angles of elevation and depression and trig ratios to solve problems. Story time, Romeo and Juliet. Once upon a time, there was a nerdy young man named Romeo and a beautiful young lady named Juliet. Julia lived at the top of a very tall apartment building, and Romeo lived at the bottom of the neighboring apartment building. Most days, Julia looked straight across the other building, but sometimes, though, she would catch the very nerdy Romeo checking her out from the window below, and this made her severely depressed. Romeo also spent most days looking straight across to the other building, but once in a while he would see this beautiful vision called Juliet standing at the window above, and his heart would pitter-patter, and his mood would suddenly be elevated. And thus goes the story of Romeo and Juliet. To sum it up, when you draw a line and you have two parallel lines, this is like a transversal. This angle that is going down from up down, this is because it's going down from, this is Juliet. This angle is called depression. This angle that's formed here is called elevation. Okay? So angle of elevation is the angle between the horizontal line and the line of sight when an observer looks upward. So this is the angle of elevation. When you have somebody, this is the angle looking up. Angle of depression is the angle between the horizontal line and the sight when the observer looks downward. So this one is angle of depression. So they are alternate interior. Actually, they are congruent. So how do they relate? How the angles of elevation and the angle of depression relate? So here you have a box and you have two parallel lines. You have two diagonal lines, and we're going to identify whether it's elevation, depression, or neither. So here you have, this is depression. This angle is depression. So angle 1 and 3 is depression. Please write D and D. And then this angle that's looking up, that's elevation. Angle 6 is E, write E next to 6. And angle 8 is also elevation. The rest of the other angles are all neither. So please write N for all of the other ones. And write D and D here, E and E here. So depression and elevation, they're like alternate interior angles. They're actually congruent because you have two parallel lines. So angle 1 and angle 8, they're congruent. Angle 3 and angle 6, they're congruent. So we're going to use this concept to do some word problem. We're going to solve our problems by drawing a picture, and we're going to actually use trigonometry ratio, cosine, sine, and tangent. So let's take a look at first example. And when we do this, I want you to draw a right triangle, and I want you to set up proportion. At the circus, a person in the audience at the ground level watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform in the angle of elevation from the audience's members' line of sight to the top of the acrobat, which is 27 degrees? First of all, we're going to change the 5 foot and 6 inches to 5.5. So when you convert this to inches, it is 5.5. Okay. So this person is 5.5. He is standing above, so 25 feet above. So from the ground to where he's standing, this point is 25, and his height is 5.5 feet. So we're going to add these up. Okay, so we just changed this, so I meant 5 feet, not inches, sorry. So 5 foot 6 inches is 5.5 feet. So what we're going to do is 25 plus 5.5, which is 30.5. Now you might wonder how I got 5.5 foot. So there is 12 inches in 1 foot, right? So 6 inches is half of a foot, right? Half of a foot is 0.5. So if I want to change 5.6 inches to feet, it's 5.5, 5.5, because 6 inches is half of a foot, okay? That's how I got that number. So this side right here, I want you to draw this right triangle. This leg one is 30.5, because you need the 25 from the plus the height of this person. And then we're going to do this and this angle of elevation, because you're looking up. When you're looking up, this angle of elevation is 27. And we want to know this bottom right here, the base, okay, which is, we're going to write x. So please draw a right triangle, right? 30.55, 30.5, x, and 27. Now, when we have an angle, we have two sides. Look at this. From this angle, we have opposite over adjacent, because this is always hypotenuse. When you use opposite of adjacent, what trigonometry are we going to use? We're going to use tangent, because TOA, right? Opposite of adjacent. So you got to remember that. So we're going to write 30.5 over x. This is the opposite. We don't know the adjacent, but we're going to write x. So what we're going to do is solve x. So what we're going to do is put over 1, cross multiply and divide. In order to find x, we're going to do 30.5 divided by tangent 27. Please open Desmos and do this with me. I want you to type 35 divided by tangent 27. You can pause the video and try. And you should get 68.691367 blah blah blah, right? So we're going to, oh, I apologize. I meant to write 30.5, not 35. So 30.5 divided by tangent 27, please do that on Desmos, and you get 59.859. So we're going to use 59.9 feet. So from here to here, it's 59.9 feet. So if you use an angle and trigonometry only for right triangle though, you can find the missing side, okay? Because we're looking at the audience members' site, okay? So the platform on the bottom right here, base, okay? Let's try another example. Example 2 says, a wheelchair ramp is 3 meters long and inclined 6 degrees. Find the height of the ramp to the nearest 10 centimeters. So if you want to change from meters to centimeters, you're going to multiply your answer by 100, because 1 meter has 100 centimeters. So we're going to draw a right triangle. We're going to write 6 degrees. Inclined means going up here. So that's going to be 3 here. And we're going to find the height of the ramp. So this is the angle. We have opposite and hypotenuse. That's SOH. That's sine. We're going to use sine, okay? So you look at what they have. So sine 6 equals x over 3. And then when you do this, you're going to multiply sine 6 times 3 to get the x. That's how you get the x. Cross multiply if you were to put over 1. And when you do this on Desmos, I want you to put parentheses around sine, so it doesn't multiply by. So if I don't do that, it's going to multiply 6 times 3, which is 18, and sine 18, which what you don't want to do. So you want to put parentheses around sine 6 and then multiply by 3. So everybody, please try that on decimals, please. And then you get here 30.31358. So I'm going to round to 36. And then you're going to multiply this by 100, which is 31.36. And because we're multiplying by 100, because we're going from meters to centimeter. So to the nearest tenth, because it says tenth, we're going to write 31.4 centimeters. Let's try example 3. Example 3, we have Vernon is on the top of the deck of a cruise ship and observes two dolphins following each other directly away from the ship in a straight line. Vernon's position is 155 meters above sea level. So let's circle that or underline that. And the angles of depression of the two dolphins are 35 and 36 degrees. Find the distance between the two dolphins to the nearest meter. So when you're looking down, the angle is depression, okay, angle of depression. So it's 154, and then one, it's 36 degrees, and the other one is 35 degrees. So depression is when you are here looking down, right? So this is 36 degrees and 35 degrees. So we're going to do 36, draw a triangle, and then we're going to use 154 over x, 35, 154 over y. So we're going to look at this from this angle. We have adjacent over opposite, right? So that's going to be tangent. We're going to use TOA. So tangent 36 is 154 over x. We don't know the x. And that's going to be, you're going to do 154 divided by 30, tangent 36, to find the answer, which is 211.96. If you do that on decimals. And then we're going to do another dolphin, which is 35. Tangent 35 is opposite, which is y, over, we can use z over 154 adjacent here. So we're going to, sorry, and then we're going to do 154 divided by tangent 35, which gives you 219.95. So this is the distance. This is where the dolphins are, and we're going to find the distance between these two dolphins. So we're going to subtract 219.93 minus 211.96, which is 7.97. So the distance between these two dolphins are 7.97. So that's the answer. Let's try example 4. A pilot is flying 10,000 feet and wants to take the plane up to 20,000 feet above over the next 50 miles. What should be his angle of elevation to the nearest tenth? So from the ground, he's 10,000 above, and then he wants to go another 10,000. So from here to here, it's going to be 20,000, right? So we're going to draw this is where plane is going to be from here to here. So elevation, so this is gonna be the angle. So we wanna know that angle actually. So, and you have opposite, which is from here, it's after 50 miles he goes. So from the plane here, let's say that's the plane, it's gonna go for 50, and then from there he's gonna go up 10,000 more. So this right here, from here to here, is 50 miles. So we're going to do tangent x is opposite, which is 10,000, over 264,000. Now, how did I get that number? You need to convert miles to feet. 1 mile has 5,280 feet. So you're going to multiply these two. 50 times 5,280 is 264,000 feet. So we convert it because this is feet. 10,000 is a feet, that's his feet. So we're going to use opposite over adjacent, but we just converted 50 miles to 264,000 feet. And you're going to divide these two numbers. Now I'm going to teach you something new. You're going to do 10,000 divided by 264,000. Put them in parentheses. But in the front, click the front part. Go to the front. You're going to actually do tangent. But you see this tangent to the -1? If you click on that, it will convert into degrees. So if you go to function, right, you see tangent, but next to tangent, you have this to the -1 power. When you're going from ratios to degree, you use this -1. So what you're going to do is press this, parentheses, and divide these two numbers. You get 2.169257. So just round to the 2.2. You're going from ratio to degrees. So when you do that, you're going to use tangent to the -1 power button. So the answer is 2.2 degrees. So please pause the video and try this using this on the keypad on Desmos, please. Let's try that again, another one like that. Sorry, let me go to that question. Find the angle of elevation to the sun where a 7.6 meter flagpole casts an 18.2 meter shadow. Round to the nearest tenth of a degree. So this is another one where you're going to draw a right triangle. The sun's right here. That is the flagpole is 7.5 meter flagpole, and the cast is a shadow, which is 18.2 meters. We want to find the angle of elevation. So angle of elevation is here, right? So that's going to be opposite of adjacent. So we're going to do 7.6 divided by 18.2. But we're going to find tangent for that. So what we're going to do is click on the tangent to the negative first number. That's going to change the ratio to degrees. And we're going to type 7.6 divided by 18.2. Please open Desmos and try this with me. And then this goes from ratio to degrees. When you're going to convert to numbers to degrees, that's 22.6645. So that's how you change to degrees. So we're going to round to the 10th. Says that. So 22.7 degrees. So that will be the answer. So just remember, when you're going from ratio to degrees, instead of just regular 10, we're going to use 10 to the -1. Same thing for cosine and sine. These are when you're changing the ratio to degrees, and put parentheses around the ratio, okay? So this will be the degrees.